Hey everyone, welcome to Devs in the Shed, episode 2. My name's Matthew Coles. I'm a Principal Technical Account Manager and I'm working at AWS. And alongside me, I've got my colleague Paul Kukel, who is a Senior Solution Architect working at AWS, both from the Australia team. So just to kick off, just a little bit of a refresher. We're only 2 episodes in, so I kind of wanted to kind of reiterate why we're doing this show. Paul and myself, we love to play with IoT devices. We really like to tinker with a whole bunch of different things within the shed. So we kind of moved our setups from inside our houses out into the sheds to do this show. And the idea is that we can get hands on with the tools, but we've also got the keyboard and mouse if we want to do a little bit of code. So, Paul, episode 1, we're going to finish off that CDK stuff. We do have a little bit of apology. I'll talk about that in a second. But we do need to prepare some devices, some Raspberry Pis for future episodes, I feel. So I think you've got something special in store. Yeah.
Yeah, so I've got a bit of hands-on today where we'll finish off the original project, but today I thought we'd show a little bit of using your Raspberry Pi, connecting to the breadboard, lighting up some LEDs, like maybe a flashing light, and a little bit of the Python code that shows how that works. And really, we should be able to squeeze that within this show. And maybe in future shows we can come back and use some of that with some other connected AWS services. And also we'll go through how to read the resistance on a resistor as well and explain what a resistor is. If we get stuck, Matt and I will have to bumble off each other because we did do a little bit of a practice to read the resistor charts, and we sort of had to scratch our heads and think about it. It's been quite a long time since I've used the resistor chart, rather than just like picking one out of a drawer that I know is a specific resistance value. But
go ahead, Paul, sorry.
Yeah, I'm just keen to see whether we can get all of this working in CDK v2 and get our application up and going. So I'll hand it over to you and we'll see if we can pick up where we were last time.
Yeah, no problems at all. So I'll take it from here. I'll get my screen sharing working in a second. We're doing the best that we can with the setup at the moment, so hopefully everything's really clear in the stream. And as we start showing components on our desks, hopefully that comes through fine for everyone. There's a little bit of tight reading to do, but we'll do our best. Where is everyone from, out of interest? Yeah. Do we have any other Australians, anyone from Singapore, anyone from the US? Where is everyone from? Just let us know in the chat.
I think Matt and I have both got a bit of a homebrew setup. I've got my iPhone set up and counterbalanced with like a heavy tape measure to get a good camera view of the breadboard and the Raspberry Pi. But yeah, over time we'll probably get better with that. Yeah,
I think so, definitely. Maybe there's a Raspberry Pi webcam project in store. I do watch some really prominent Raspberry Pi enthusiast channels, and I did see someone built this awesome webcam, so you can turn a 0 into a webcam that you just connect through USB on your computer. So maybe that will help with a bit more of the focus. I can see the chat's happening now as well. So we've got a lot of people from the US. Shout out to everyone. TW, is that Taiwan? If so, that's pretty cool. Yeah. And yeah, excellent. Well, awesome. So we always bomb our accounts, just FYI. So when we finish each episode, we destroy the account. There was a little bit of leftover. We got caught up with a particular issue from yesterday or last week, actually. So when we cleared up AWS CDK and this example app that we did have, we did run into a problem in that process. It didn't delete the Route 53 records. And so we're just waiting for a bucket to come back and a Route 53 record to come back. I did find a bug log. So that just basically means what I'll do is I'll walk everyone through the last of the changes that I had, because we ended the stream with probably only like 2 things left to do. Actually 3, I correct myself. We basically, in the app that we're porting from CDK v1 to v2, so using that new developer preview, if you missed the last episode, we had to change a lot of the lib imports, if I can get my selection right. So we did that at the top of this existing app. We went into CDK JSON and we removed all the context because there's 4 particular flags that you need. for CDK2 if you need to use them. Whereas a lot of the V1 flags could just be removed overall, and CDK V2 is going to do some magic to work that stuff out, I'm assuming. We then, once we had the imports right in the wildcard stack section of our app, we then went through and we made a little bit of alterations. So we put like CloudFront on the top of the origin axis. We put S3 on top of the bucket, and each of those each of these refer to the way that we did our imports. So it's kind of like catching everyone up to speed. I'm going to paste a link to the repo as well, just so everyone can see
Yeah, good. I was just about to do
the
that,
repo
mate.
that we're working on. Yeah, put it in. That would be awesome, Paul.
Yeah, I'll do that.
Excellent. I can see Simon's comments. He's surprised a lot of people are in the US up at this time. I actually think it's quite reasonable. I think it's like 6 o'clock to 8 o'clock, depending on where you are in the US. Some people it might be 10 or 11. I can see someone can't stop coding. I think that's the same as us on the stream here. Okay, so getting back to what we've got here. As I did run into that bug, I wanted to take everyone through the last of the changes that I made. So we basically imported construct from the construct library. So we added that one in. We then changed the scope from cdk.app on line 15. We changed that to construct. So that kind of enables us to work through V2. And that's all documented in the migration guide, actually. So if you do want to check it out, I'll just paste the link in the chat.
It was interesting through the week. I was chatting with one of my friends who was migrating one of his applications across and ran into one of the experimental libraries that he was trying to use and realized that, that could be one of the blockers at the moment going across to CDK v2. That the experimental libraries aren't there. And at the
Amplify,
moment,
AppSync. What are the ones, Paul? I think it's those two, but I'm not aware of other ones.
It was around AppSync. It was exactly around AppSync.
Yep. Nice. Okay.
Yeah, I didn't look at the others, and we did spend a little bit of time. A very small, tiny amount of time trying to look at it. We couldn't figure it out. We ran out of time. I thought it might be something we could investigate at another later stage in the show.
Yeah, I mean, my speculation. We were messaging each other over the like yesterday, I think it was on this. My speculation would be to do an import of the V1 experimental library and see if V2 functions for that. I don't know if that's going to work, but maybe that's something we can check out. You're right, Paul, and see if we can get working, because some people are using experimental libraries. Like AppSync's really good for mobile and web dev because you don't have to worry about as much in terms of version changes of APIs, like damaging your app as you build out like different API components and update the app itself. So AppSync's really good from that perspective. But it's also really good for just, I want all the things, give it back to me, right? So AppSync as a service is a little bit different to a REST-based API like API Gateway, where you go, I want the data from this source, and I want these things returned to me. And now I've got those things like the post ID. I'll make another call. That post ID is going to give me access to another table with like details on a post. And so you kind of have this like multi-turn or code that kind of iterates through a bunch of steps to collect and gather data to create a particular view. Whereas AppSync, it's all like, just here's all the things I want, just give me all the things, and AppSync works out that logic, which is cool too. Anyways, I'm getting myself distracted.
Cool most of the time. Maybe one day we can revisit that, because I've seen where resolvers end up having an exponential effect and can cause a real slowdown if not used correctly. Yeah,
that's true. Yeah, I need to explore a little bit more on that as well. I remember us talking about that a couple of weeks ago. So the next thing that we did do is the viewer certificate. The old method that we're using in the app had changed up a little bit. So to use an alias, this is the code that we popped in. So this is all documented on the V2 wiki. So if I go into let's go ACM, I'm guessing. Let's just quickly try and find it.
I think that was part of CloudFront.
CloudFront, yep. Let me try and find where this was, just for anyone that's interested.
So once we do get this working, we'll set up a secondary branch on that repo, just so that anybody wants to look, you can see the differences. And probably what we'll do is we'll leave the PR open so that it's really easy to look at the diff as well as having a branch.
Yep. CloudFront web distribution is what I probably want. Searching is a little bit off today. Okay, here we go. Yeah, this is it. So viewer certificate is what we ported over to, and there was a good example of what this looks like, if I remember as well. So all the properties that we need.
I know that this took us the most amount of time when we were sort of going through this in trial mode.
Yeah, that's right.
We just got really stuck. Everything else we got through really quickly, and as you saw basically in the last episode. But this bit we got quite stuck, and we had to fiddle around for quite a long time, seeing what had changed, how it looked like in the past, and what was going on here. It wasn't as clear as we thought.
Yep. Yeah, so this was the trick. We migrated this over and allowed us to basically grab the certificate that we needed for SSL. Now, the very last thing that we did change to get this all working and ported over was in the bin directory, we opened up CDK wildcard static out, and we changed the imports from AWS CDK to -lib, and then we did star as CDK as the import, and then we loaded in the constructs as well. So we only changed the 2 imports, I think, effectively in this particular file to get this working. And so with all of those changes, I was able to successfully deploy at a later stage last week on that date. I did want to show everyone a fresh deploy where I made those modifications again, but it looks like we were out of luck. But that's okay as well, because it takes a while to deploy these things, and Paul and myself were really keen to get, I guess, the Raspberry Pi project started anyway.
Yeah.
So going back, I'll stop sharing my screen. Going back to you, Paul, you've got a whole bunch of stuff set up at home. Let me get that up on the screen for everyone to see.
Sure.
And I might make your phone the bigger view, and so we can see kind of what you've got pointed down at your desk. Do you want to explain to us what you're trying to achieve here? I don't see a Raspberry Pi, but I see a strange SATA cable or something, IDE cable, old school cable.
Yeah.
Yeah.
We were just discussing that before the stream. That it does look like an old IDE cable, except if anyone remembers, the IDE cables, the old ones, had 1 pin blocked out in the middle. So this pin has every pin exposed. It's just slightly a bit different. But yeah, look, I got two sons, and they both like to see what Dad is doing when he's playing with some sort of electronics, and so I said, look, let's go ahead and make a couple of lights flash, and we thought that might be a good introduction and a base for something that we might extend upon further in the future. And so I got the Raspberry Pi, and I have played with Arduino before, but we decided to use the Raspberry Pi and the GPIO pins and ports that are on that.
So that cable you just basically plug in, right? And all it does is it basically just extends it onto the breadboard, right?
Yeah, so I'll move the Raspberry Pi into the view here.
Yeah, okay, yep.
You can see, like, this is my Raspberry Pi here. Yep. So here's my Raspberry Pi, and I plugged this board directly into the I/O pins on the Raspberry Pi, and that just extends it out so that I'm able to use it and see it easily on the breadboard rather than having to run individual wires over the from the Raspberry Pi onto the board. Oops. And yeah, you can see that the camera setup wasn't so great there.
Going to bring the camera back for everyone?
Yeah, I'll bring the camera back on just a second.
Yeah, here we go. We're back. Just whilst you're doing that, I guess who's got a Raspberry Pi in the audience? Has anyone got the breadboard as well? You can rewatch this, follow along if you want to as well. Our plan was to maybe eventually install AWS Greengrass on one of these devices. No, we've got someone without the Raspberry Pi. That's okay. We've got somebody that was an electronics firmware engineer. That's cool. So straight out of
That was
university. Yeah, Simon actually. Yeah, and never actually learned to read resistors from bands, but always had a multimeter with him. Multimeter. I can't even talk today. I give up on that. Okay, and
I've fixed that back up again.
you fixed it up. Yep.
Yeah. So yeah, we're still running a pretty homebrew setup here. I accidentally just knocked my tape measure stand. So let's see how we go. Okay, so this extender board goes directly onto like what we call here, this is a breadboard. And basically what I can do is like all of these holes within the breadboard, I can put in either wires or some sort of like electronic devices. And if we have a look here, I've got a couple of LEDs. What I thought we'd do is we'd just make these lights go on, like, so, you know, green, yellow, red. And run each light for like a second and just run through a loop with that and show how that works and how we can set all of that up. On the Raspberry Pi, so this is running Raspbian, so the stock standard Raspbian OS, and they come pre-installed with Python 2.7, so we'll write our program in Python. There was nothing additionally that I needed to install on the Raspberry Pi. So, you know, all you need to do is basically image your SD card, plug it in, get a network connection for that Raspberry Pi, and you can go ahead and start working with that. The very first step that I've done here is and if we do look really closely, we can see that there's the ground, so that's a negative. And I'll pull the negative out and I'll just have that ready. So I've got one single wiring. And from this point, what I'll do is I'll bring up the code and I'll show what the code is doing so that it starts to make sense as I start to plug in some componentry into the board. So Matt, do you want to just bring up that? Actually, I think
let me get your screen share up for everyone.
Yeah.
Here we go.
So on my Raspberry Pi, so I've SSH'd across my Raspberry Pi, and you can see a little bit earlier I was playing with the Raspberry Pi camera, and I made a couple of different images there. But I got two files here. So clear, all I was using for that was to reset all the switches and lights. So we'll have a look inside the code. Lights and we'll see what's going on. So if we start right at the top, I basically define a couple of variables. So the GPIO, I just called them all GPIO, so it makes sense. And one of the tutorials or the demos I was walking through did that as a convention, and I thought that was really clear. It knows the type of variable I'm interacting with. But basically, I'm saying like for red, amber, and green, I want to set those for one of the I/O pins to be a specific number. So that means the red I/O pin will be 22. And so when I go ahead and use my code to interact with that, if I say in my code, turn on the GPIO pin 22, I can say turn GPIO pin red, and that will turn on 22 on the device. Now, just quickly to show how that works, if we put the Raspberry Pi piece back up, the breadboard, Matt. So just that tiny little bit. Now, if we look really closely on this board, and I'll try and make this as clear as possible, we can see here GPIO 22, and I think the other one I'd used was 17, and there was another one, I can't remember the number, we'll check it when we go into the code, but on the other side as well. So those are the pins that we're going to connect. So if we look at the way this works, these pins are really, like if we take, for example, pin 22, this pin is aligned perfectly in here, which means that if I plug a wire into here, I'll be connecting to GPIO pin 22 off the breadboard. And so I'll just go back to the code again.
Yep.
And look at some of the, that's good. Keep them both up like that, Matt.
Cool.
So people can see what I'm going to go ahead and do. Now I'll go back to the code and I'll say, so in GPIO pin 22, I want red. So what I'm going to do now is I'll take one of these specific wires here, and I'll say GPIO pin 22. So that
and call out in the chat if this isn't readable. Just I want to make sure that everyone can follow along.
Maybe I'll see if I can increase that font size. I will post up some links to that as well. So Gpio Pin 22, which is over here, I'm going to place that on, I'll do that on this side of the board. And if we have a look at like one of our LEDs here, when you do work with the LED, an LED is not like it's not like a typical light globe. So a typical light globe, you can have the polarity, which is whether it's positive or negative voltage that's coming out, running either way. An LED stops, like it only allows voltage to run through like one way. I'm sure Simon will know, how this works, but if you have a series of LEDs or diodes, you can, start to like convert AC to DC. We won't worry about that for today, but effectively what it means is when we look at our LED, we see that there's two little legs at the bottom, and one of them is just slightly longer than the other. And that means that the longer one is going to need to go to the positive. So the GPIO, the outputs is the positive side, and the black is the negative side. So we're going to want this specific light, the long one to go into the positive side, and the short one to go into the negative side. Now, if we just place that in there, at the moment, this will do absolutely nothing, because all we've got, even if I ran the program, was positive would go to one side of the LED, but it would go nowhere else. What I will do is to connect to the other side. Now, if I took the negative side and plugged it directly over here, which is on ground, which is negative, the LED would light up. But these are pretty soft LEDs, and we're putting out, I think on these GPIO, it's 3 or 3.5 volts that's coming out of that. So we're going to use a little resistor, and the resistor will drop that voltage down a little bit lower, and just push a little less power through that light. And it'll still light up, and it'll still be really bright, but it'll be a little bit lighter. Now, as Matt and I sort of spoke at the start of the stream, there's like, if we look here, this is what a resistor looks like. I'll try to show it. A resistor basically reduces, it makes it harder for electricity or for current to travel through specific areas. So if you want to have less electricity moving to a certain area, you use a resistor. And a resistor is, they are measured in ohms, and there are small fragments of ohms there as well. I'll just check if anybody's asking any questions as well. And so
someone just missed the start of it, actually. So maybe just to reiterate, we were playing with CDK at the very start. So the project that we're doing last week, we just showed the last little bits to finish off. Now, at the moment, we've got a Raspberry Pi, and we want to get a basic kind of relay going with a few LEDs to make sure that we can use the I/O ports to do some IoT projects in future episodes. So, so the Raspberry Pi, we're going to connect to 3 LEDs, make a traffic light. There's code on the right-hand side of the screen. On the left, we've got the breadboard with the LEDs that we're working through. And the idea is if we get all this successfully set up, it means that at a later stage, we can start to do like some AWS Greengrass projects or something, and maybe have these controllable through the internet, each of the LEDs.
Yeah, I think that would be the end goal. And look, we've said it so many times that as devs, if you try to start too deep, we'll get lost in all the mess that goes along with what we're doing here. So that's why we thought we'd start with something really easy and say, all right, let's demonstrate how it works, and then go ahead and connect it up so that maybe we can have a bit of interaction and get build an API and allow our users to go ahead and control what light they want to go on or something like that. But as I was saying earlier, if we look at the resistor here, and we look at these resistor packs that I've got here, we can see that this is 220, and that is the ohm symbol. It sort of looks like I don't really know what that symbol is, but
it's like the Greek Omega symbol or something,
Omega?
isn't it?
Yeah, that's right.
Hopefully, I get that right.
Yeah, I thought it was that. I just didn't want to say it. I wasn't.
Does anybody know in the chat? You can jump in and tell us if we got it wrong.
I think that is right. Yeah. And so when we think about like how to read what the resistance is, and as Simon said earlier, if you had a multimeter, we put on a multimeter, we'd be able to see what the resistance was. And actually, I've got a multimeter here. I'll put it on and see if it works properly the way I expect it to work. I was having some problems with this multimeter. It's not a very good one. anyway, we'll just do it manually. We'll work it out manually. So this here is the card, and is that upside down, Matt, on the screen?
It's actually yeah, that's better. That's properly yep.
So this is like how we go ahead and we read the resistance of a resistor itself. And so what we do is I'll hold the resistor here as well, and we'll have a look. We'll work through this together and see if we can work it out. So if we have a look at the little resistor I've got, it is a blue resistor, and it has like a series of bands. The first band is red, the second one's red, the third and the fourth are black, and the end one is a brown. And so, yeah, that's right. And so the way you read this and the way you interpret how much resistance that has is we look at the first band. So if we look at this first column here, we say, what is that? Well, that's a 2. And then we look at the second band, and that's a red as well. So that's a 2, so we're 22. The third and the fourth band are both black. So at this point here, there is they're worth 0, so and a single multiplier, so that it's worth nothing. So we're still at 22. And the final one is brown, which is here 10, and that's a multiplier of 10. So we've got 22 times 10, and so this is a 220 ohm resistor, and that's effectively how you go ahead and work out resistance. When I was really young, like my dad was an electrical fitter, I knew how to read resistance bands, and he definitely did. And people that are working with this, often might as well. You can just pick it up and work through it. This probably reminds me of when I was, in those first uni days when we were using binary arithmetic, and we knew how to do it, in the top of our heads because we had a lot of exams and tests about that. But I certainly forgot how to do that. And so, Matt and I, when we were sort of preparing yesterday, we thought that might be interesting to go through, but we were struggling ourselves for the first, minute or so trying to work it out.
Yeah, I think the other thing is there's nothing wrong for this particular project. Like if I remember correctly, the Pi has 5 volt outputs at the top, but there's also a 3.3 volt output, right? And those are always going to be outputting. Whereas the GPIO ports, effectively, through code, which is on the right-hand side of the screen, we can set the energy level that's going to be through those ports. So if GPIO is set to low, then effectively for that port, it's not going to let any power through, or it's going to let very, very minimal. Whereas when you set it to high, it's going to open up that port to let out 3.3 volts. Yep. And so, one of the things was like we were comparing projects because it's like, let's go and do this and get this working over the weekend. And I ended up using like 1,000 ohm resistors. So mine was something like, if I go back to the chart, it was like brown, black, brown, or something like that. So it was 1,000 ohm, whereas Paul decided to go to 220. But I think as long as you've got some form of resistance, you're in a good spot, right? The whole point of having the resistor there is to make sure that we don't burn out the Raspberry Pi's circuitry. So yeah. I think anything over 100's kind of safe for this type of project if you're going to have an LED, a resistor, and all that mapped back to your Raspberry Pi.
Yeah.
But on the safe side, I went to 1000s, but my light's a little bit less bright than what Paul's is, right? Whereas 220 is going to let a bit more energy through, so his bulb's going to get brighter than what I had on mine.
Yep. I'll try if my multimeter works here, just to show how that works. So sort of move this along just a little bit.
Yep.
So you can see here that I've got a multimeter. Now, if I was to, the cables are sort of hanging down a bit. But if I was to have a look on the board and I was to pick where the ground is, and just to confirm that 3.3 volts. So if I pick ground here and then 3.3, I'm on multimeter. The cables must not be in properly.
That's okay. We do have a comment. Is the resistor for saving the Pi or the LED from burning out? We don't care about the LED, right? We get packets of them for only a couple of bucks. It's the Raspberry Pi that we're trying to ensure doesn't burn out. So the Pi will shut itself down if it has too much voltage run through. But we don't want that to happen at all, right? Because there's still a chance it's going to get damaged. And I've seen people on the internet that just don't have a resistor at all. It seems to work for them, but I like to play on the safe side. We've got a compute shortage, like globally, of like Raspberry Pis and general desktop computer processors and laptop processors. Pies cost $100 or something like that in Australia for the kitted out ones. And so, yeah, it's all about protecting our Pi, making sure that we don't short circuit anything, burn out any of the board, whatever.
Yeah, I think that's what it is. Like I've probably got like, I don't know, 500 of these little LEDs. And so, yeah, I just want to make sure that I'm not going to do any damage. Well, one, I guess, to the LED if I was to, overpower it. And two, to make sure I'm not doing any damage to my Raspberry Pi. Now,
Yeah.
I must have been running the program, which is why this light is probably stuck on. So if I quit quickly.
Yeah, I was actually looking at that. I was like, so generally you're supposed to actually, as you're building out things on the breadboard, you're actually supposed to shut your Pi down and then boot it up once everything's like kind of stabilized, plugged in where you want it, and then you can boot up your Pi and then run the code on the GPIO ports. We live dangerously only because we're live streaming. We don't have time to turn down the Pi and then turn it on again. It's just a call out on that, I think.
Yeah, you don't have to worry about like hurting yourself. The voltage is really low, but you could damage the Pi if you accidentally short out something. For whatever reason, that digital multimeter wasn't working at the moment. But at the moment, right now, compared to our code, what we've got is we've got everything wired in that says if we turn GPIO port 22 on, then we should be putting power through to that. And so part of our code would already start working at the moment if we were to go ahead and turn this on. What I'll do is I'll follow those same steps for the amber light. So again, with the amber light, I'll look of amber LED. I'll look for the longer of the legs. And I'll put that on the side that I'm going to use for the positive. Let's just put that in there. For amber, I will use this orange wire. What was the pin code for that? Huh? Can you read it?
The pin code for yellow.
I have to scroll up a little bit in the
or amber, you're gonna have to scroll up, yeah. 23.
So that's 23. So I'll find 23, which is on this side. So it's just over here. And again, I'll do the exact same thing. So I want to make sure that whatever, actually the resistor could go on either side. I've chosen to put it on the negative here. And one thing to also note with resistors, so if you see this one here, like the red bands on that side, a resistor will work either way, exactly the same. So I can go ahead and put the resistor in either way. It doesn't really matter.
Yeah, that's a good call out. By the way, we have another comment. Is there a link to the project or the repo? We don't have a repo up for Paul's code just yet, but I did something almost the same myself over the weekend, and so I've just pasted in the gist from GitHub. So it's a really simple script, and my project, I think the difference was I wanted each of the lights to come on in sequence, and then I wanted all of them to flash at once. So you can take that, you can run that on your Raspberry Pi, you can follow along. It'll work exactly the same way.
Yeah,
and it's just in Python.
The more feedback or the more ideas that people have or our audience has is probably something that we'd prefer to tackle, because we're just thinking up random ideas here and sort of working away at something that'll eventually do something fun. At some point in time, we thought about using what was that called, the e-ink, and enabling people to maybe play noughts and crosses via an API or something like that. So we're happy to post up all of our repos, but yeah, Matt's one is really similar to the piece of code that I've built up here. So I'll go ahead and I'll put in the green as well. So for the green, same thing again. We'll look for the longer leg, and I'll put that on the side that I'm going to use for positive. So I'll go ahead and I'll put that in there. And I'll find another resistor here. And I'll put that in as well. So as we were sort of saying, like I am doing this with it turned on. If I was to accidentally connect, let's say that the GPIO port directly to grounds, that probably would not be good for the Raspberry Pi. Might last a little while, but it probably wouldn't last very long. So that's kind of one of the reasons why we, you should turn it off, or maybe just disconnect the main ribbon while you're going ahead and installing the componentry. So for the green, we use a green wire for that one. What was that? 24. So we'll go ahead and we'll plug that into 24. Now, this here should be enough that we can go ahead and run that bit of code. So if we just go back to the code segment and we have a look at what that does. So we've set up our pins. The pins match where we expect our lights to be. So the positive of the LEDs is mapped into the GPIO output pin onto the Raspberry Pi, onto the board. I've SSH'd to the Raspberry Pi, so I have direct connection. So I'm using Vim to go ahead and edit this little Python script here. And what I'm going to do, the next bit is you do want to go ahead and set those up. So register within your application that you're going to be providing output to those specific pins. So those pins are going to be used as an output, not an input. If it's an output, it's going to put out some voltage. If it's an input, then it's going to expect that 3.3 voltage to come in, and then you can determine whether or not that is working and reading how it is there. And so the main piece of this application basically says, when we want to start our application, we're going to go ahead and set all of those GPI pins to false. So it's just, true or false, it's just binary. So it's high or low, or like voltage or not voltage. So we'll set them all to false, so they're off. And then inside a while loop that stays on forever, we'll turn on the red. Then we'll turn off the red, we'll turn on the amber. Then we'll turn off the amber, we'll turn on the green. Then we'll turn off the green and start the cycle all over again. And so that's the loop there. Don't worry about the other settings that we're doing with motor and switch that's there. I'll just double check that. I hadn't run that. I hadn't run this since my son was editing it. I think we can delete this line here. We're trying to run a little motor. Let's see if it works. So there we go. As we can see, it worked the way we expected to, which is good because connecting all the wires up and plugging this in live, just like the multimeter didn't work for whatever reason. But I thought, actually, I've got another multimeter, and maybe I'll go ahead and show what that looks like if we were to put that little multimeter on. So it's a little digital one. You might not be able to read it's a little analog one. You might not be able to read exactly what's happening, but you should see that when the light pulses on for the one that I'm going to hold it on to, we should see this needle move up. And we're on a scale of this is like as a maximum of 15 volts DC. So there's 15 volts. We should see it like just in front of that 3. So I'll go ahead and I'll put that on. So I'll do it for pin 24. So I'll do it on the green light and ground on the other side. So just touch down to there and there. And then we can see the meter going up and down when the green light goes on. And of course, we know that is happening because the light is going on, but it's interesting, it's interesting as well to see like that it is 3 volts coming out of that. And that's how it goes into the works. So the other piece that I thought was, interesting enough to demonstrate was, and if you could see there in that log, I had a switch, and the switch is to determine whether or not some sort of we're reading something back out from the real world. So reading whether or not a switch has been pressed or not. And so if we look here, there's a GPIO switch is at 17. And we do the exact same thing, except within the loop. Actually, so I'll restart that. So for the switch, we're setting up a GPIO pin for port 17. We're going ahead and we're setting up that switch port, which is 17, to be an input. So this is we want to read some current from this, and that's going to be able to determine when we look through our application, if we've put 3.3 volts into this, like all the way through as a circuit, we'll be able to determine whether or not the switch has been pressed or whether it hasn't been pressed. So at every iteration of the loop, I just call this method that I wrote that said, check whether or not the switch is on or off, and output that to the screen so we can go ahead and look at that. So to wire up the switch to this, which we'll use it to do nothing other than determine whether or not the switch is on or off, but we could use it to control something happening, like turning a light on or turning a motor on, or anything we wanted to go ahead and do there. And that might be, in a future project where you press the button or you press the switch and that goes ahead and, turns your aerial on the roof on or something like that. But I do have here a tiny little switch. So if we see that, and if you probably can't hear it, but there's a tiny little clicking when I press it.
Yeah, I can hear a little click. Yeah, it's coming through.
A little click there. So we'll plug this switch in, and we'll do the same thing either side. Actually, we don't necessarily need a resistor for this. That'll work without it, but I'll put a resistor in just so I don't have like bulky wires all over the place. So the switch has got 4 pins, and I can't remember which side of the pin is the ones that work all the way through. I think they both work, but we will go ahead and we'll just bridge that across with a resistor again, and I'll use blue for the other side. So I can use this side here, and I think it was, what was it, 17?
Yeah, I think it was 17, but scroll up to double check.
Yeah, double check that. Yep, 17.
Yep.
So should be able to go ahead and application. Yep. 17. 17 is right at the top here. So 17 is here, which is right next to the ground. So yeah, I did do it properly. That's good. Now you can see that if you can hear it, like when I press and hold the button, it says the switch is on, and when I'm not holding it, the switch is off. So that just demonstrates that not only can we like provide power out into some sort of electronic equipment, and use lights and then use proper programming logic to control something in the real world, but we also can go ahead and read those signals coming back in.
Yeah, it's pretty awesome. I one of the things my wife made a comment when she saw this over the weekend, right? Because she's always interested in what we're up to. But she goes, wow, so usually you code an app, and in that app you're kind of acting with the digital world. You don't really control much in reality itself. And she's like, it's mind-boggling to see that through some Python, we really quickly can start to control elements in real life. So with that button that Paul's got, effectively, if we wanted to take that to the next step, we could use that to turn on all the LEDs. So we call all the GPIO ports to high whenever it's pressed. We can do a whole bunch of stuff now. Over to you again, Paul.
Yeah, so because Simon said an interesting comment there. I'll just put that up. And so, because what Simon said is really true, because I'm only taking that read every so often, so that because there's a sleep there, I'm doing a read and then it's sleeping for a while. So if I missed holding that button for the exact moment that I was doing a read, then you would miss that switch is off. So your program would not know that your switch is on until the next time it actually goes and reads that. So that's an interesting comment, and an interesting factual comment. And something maybe we can look at a little bit later and set up a demo that demonstrates that a little more precisely. But just going on to what we were sort of when I was playing with my son, he said, "Oh, can we turn on a little electric motor?" And I said, "Oh, I'm not really sure with how we can do this, and I'm pretty sure what will happen is if we put a little electric motor like this onto the Raspberry Pi, what would happen? Because as we saw, there's the Gpio pins will put out 3.3 volts, or roughly 3.3 volts. And if we looked a little higher up, you can see, if we look right at the top there, we can see 5 volts. So there is a dedicated 5 volt out as well. But running this little motor is probably going to take, not a lot of power, but a lot of power considering, in consideration for this, running one of those lights is going to take, the tiniest amount of power, and the motor is going to take, 10 times more of that tiniest amount of power. And so he really wanted to see that. So I did go ahead and wire that in. And, it's reasonable to assume that if I was to go ahead and connect the pins of the motor to the positive and negative in place of a light, that we would see the motor spin for a second and then not spin for another second. but like it didn't. So I was pretty sure that it wouldn't work the way we expected it to work, and that's because the Raspberry Pi. I mean, if we look here, like I'm running this off a micro SD cable. It's really long, that is actually out of the back of my router. So my router that is out in the shed has one of those USB ports that you can plug a hard drive in and run, a little Windows file share on there, or Samba file share on there. So I just power my Raspberry Pi with that. Like there is not enough power even from that device to probably be able to spin that motor. So that was something else that Matt and I were thinking about, that how we can use the Raspberry Pi to control something in the real world. So some sort of like little motor, or a servo arm or an arm of a robot or something like that to go ahead and do something. And that's where you would have like a little piece of electronic equipment called a relay. And a relay will take the output. So if we were to go ahead and put 3.3 volts in, the relay is effectively just turns on a switch, and we would have an external power source to go ahead and do that. And that's something that I ordered the part. I didn't have one, but I ordered a little 3.3 volt relay. And in another time, we'll go ahead and we'll set something up, like maybe we'll run a little fan or something like that. And it might be fun at some point in time to, maybe build out a little Twitch bot or something that, if it's really hot, because I'm sure it's going to get real hot in my shed in the summer, because I mean, it's reasonably warm in here now. And if the audience are really nice, they can, issue a command and turn on the fan for us. And if they're not happy with our performance, they can turn off the fan or something like that. That might be some sort of fun project that we can do in the future. But yeah, I'd love to hear from the audience whether anybody else is doing anything interesting with either their Raspberry Pi or IoT, or you yourself, Matt.
Yeah, I've got a few projects on the fly. I've got something that's half built in the background. I can't remember if I talked about it last week, but it's kind of like a homebrew deep racer that's running a Raspberry Pi. It's literally in pieces at the moment. I wanted to do IoT machine learning at the edge, so that's something that I've got on my radar for later on. The next one, though, is probably actually assembling like a webcam to be read to my computer. So basically using that Pi Zero that I mentioned at the very start of the stream to connect into the high quality Raspberry Pi camera that they've produced, and have a lens on that, and then basically load up the software to be able to have the Pi recognized as a webcam if I plug it into my Mac or my PC. So that's one of them. Let us know in the chat anything that you are working on. I can see someone's got theirs as a web server. Simon, again, thanks for chiming in. So that's pretty cool. I've got a clustered Kubernetes kind of Raspberry Pi set up as well, floating around somewhere inside. I turned it off because I couldn't think of what to run off of my Pi cluster, but that was another thing.
Yeah, I've done the same as well, and I think one of my friends has got several Pis running the Kubernetes cluster at home. He's not doing anything particularly IoT with it, but he's sort of got his own little cloud sitting there at home, which is pretty cool. I've done the same, and it was quite fun. I guess one of the things when you're using a Pi is like an actual computer to do some sort of web serving or something. Oh, that's great. We've convinced somebody to get a Raspberry Pi. If you are thinking about getting a Raspberry Pi, all of this can be also done on the Pi Zero. And the Pi Zero is like 17 Australian dollars or something like that. It's incredibly cheap.
Yeah, I think you can get one for about $9 from a couple of different places online. I usually call out to Little Birds, I call out to Cora Electronics. Those are the places that I usually order stuff off of, in Australia in particular. But there's heaps of really good places online that you can get things globally as well. I'm trying to think of the other one. But Mr. Scott G, you've got a good comment here as well. Yeah, Core Electronics is global, but there's also it will come back to me. But let's have a look at this comment. So running a Raspberry Pi, running Direwolf connected to amateur radio to capture audio for decoding APRS, as well as GPIO to control push to talk on the radio to trigger a transmit. That's pretty awesome. I haven't looked at Direwolf, and considering it's radio, I'm guessing you need a particular hat to do that. I'm thinking.
What's
It wouldn't be a
a hat?
4G hat, but it'll be like a radio Raspberry Pi hat. So basically, a hat is effectively similar to the extension board that we've got plugged into our Pi. You plug it on top of the pins, and it sits on top of your Raspberry Pi, and it allows you to interact with another module effectively. So similar to the Deep Racer homebrew type project I've got going, that's kind of integrating into a whole bunch of stuff as a hat on top. Yeah.
I think I've got some here if I can show one.
Yeah, I've got a couple of different ones. I've got like a temperature sensing hat, but it's not too accurate because the Pi gets quite hot itself. So you can have an LED or an LCD screen as a hat as well. I've seen those too. I've seen people with 4G modules as well, actually, but they're really, really expensive. So I haven't invested in one.
The hat I've got handy, well, it's not a Raspberry Pi, it's the Arduino. So for anybody who's familiar with the Arduino, that's, I guess, like a much more cut down version of the Raspberry Pi, where you write the code and publish it onto the chip. But if this was the Arduino, and let's just presume that was a Raspberry Pi, and this piece is the hat basically just can plug on top and provides like some additional benefits. So in this example would provide Ethernet to the Arduino. And so for your Raspberry Pi that needs like the 4G module, like Matt said, you plug something on top and it slots into those I/O slots and all those ports and those holes, and then you can go ahead and configure your Raspberry Pi to have like always internet if you're using the 4G module, which is something that we'd also thought about at one point in time, going out somewhere a little more remote, or maybe even like less remote. It didn't really matter, but we thought it'd be fun to do it a little more remote, where we have a friend that has this tiny little camping device, and when you make a fire in it and you burn wood, and that fire creates heat, the heat creates energy, the energy is converted into electricity, and we wanted to use that electricity to run the Raspberry Pi. If the Raspberry Pi had a 4G hat, then that could be like effectively online. We could have something that wasn't plugged into anything, that was like a completely IoT device, so completely disconnected from everything, but also because it's on 4G and because it will have connection back into the cloud and into AWS, then we can we could have something that was basically running some sort of little application at the edge and running that on fire rather than or running it on wood fire rather than powered from a battery or something like that.
Yeah, the battery option is the other option, right? If we don't have enough wood to burn wherever we go, or there's fire restrictions, which does happen in Australia. PiJuice has some pretty cool batteries. I was also thinking, like, I would like to get the webcam that I get set up powered on battery, and I'd like to set up some motion detection, because I have a possum that lives in my garden. He's a nice, friendly, kind of like ringtail possum, but he has a habit of eating all my herbs. So I've got an elevated herb garden with basil and a bunch of other stuff in it now. Maybe I could connect that to IoT and have like it self-water. I've seen some projects like that in the past. But anyways, I would like to kind of make sure that it can't get into the elevated herb garden as well. So I could set up the Pi Zero as maybe a security camera.
I thought you were going to say if it detected the possum coming close, it's going to blast an air horn on it or something.
No, we've got to be nice to possums. I am originally from New Zealand, and it's a bit the opposite. But in Australia, they're protected. The nice creatures are different. And New Zealand possums are about, like 5 meters high. They're insane. They're huge beasts. They're bigger than bears, bigger than drop bears, definitely. But in Australia, they're kind of cute 30-centimeter little things. They're much nicer than New Zealand ones.
Your roof and make a lot of noise.
Yeah, that's true. Yeah. So that's another thing. The last thing though is we've only got 5 minutes left on the stream. I did want to talk about how we're going to bring AWS onto the Pi, right? Like Paul and myself are complete noobs when it comes to this. We have no idea on how we're going to do this. Our plan or our go-to is probably going to be using AWS IoT Greengrass. Do you want to talk a little bit about that, Paul? We could be completely off track. So if you've used AWS IoT tools before, call us out in the chat. But maybe, Paul, do you want to explain what we're thinking, and we'll see if anyone in the audience has done it or can validate that it's going to work.
Yeah, so what we wanted to do, and that's why we sort of we started by, like, I guess, bootstrapping out some sort of little application on the Pi at the moment with a Python script, is to say, okay, how do we interact with the pins? What's the setup? How does it work? And how do we connect the wires and the physical pieces together? And so what we really wanted to do was, like, bring this back into, AWS-based services and have an API that enabled the audience to turn on a light or do something else, like maybe play noughts and crosses. For the first iteration, all we'll probably do is build an API that, when we call that API, it goes ahead and turns on, a specific light. And if we we call the API again, it turns off that light. So we were thinking about how we would go ahead and do that. And the space in the area that Matt and I typically work on is in the development area, and we, with enterprise customers. So not so much on, like, the core technologies around IoT. So we have, like, not a lot of experience, like not very minimal experience with, working with IoT or working with Greengrass. And so we were sort of looking around that, rather than just going to somebody and telling us exactly how to do that, we thought we'd go and explore that, like anybody else might want to go and explore that. And the way we were thinking about doing this was by setting up Greengrass on the device itself. And if we set up Greengrass on the device itself, that'll enable us to push functions onto that device, and effectively run, like, an environment that allows us to run Lambda functions on the device. If we're running on the device, then in theory, we should have access to Gpio pins, and so the inputs that are coming directly off that device that we're running something on. And then if we've got a function that can run, an environment like Lambda, we can package our code up and treat it the way we would, typical AWS Lambda. And for those that aren't aware, Lambda is the ability to run your code, effectively run your code as a function. So you don't have to think or worry about servers. You write a function, and you go and deploy that into pre-provisioned servers. In this instance,
and it only lives for the life cycle of when it was called as well, right? So it might live for 15 minutes and then kind of disappear as well. So it's kind of ephemeral.
Yeah. So if you were building a function that was running, like, in actual AWS Lambda, then that might be only running for, like, 1 or 2 seconds, and then you're only paying for those 1 or 2 seconds. If you run it on a device, the function might be going ahead and turning a port on and turning a port off, so it only needs to run for a second. And we were thinking to use IoT Greengrass on the device, connect that up with MQTT, so IoT of things within the AWS, and that has a secure channel from the device itself and up into our AWS account. And then we can push messages down onto that MQTT channel and be able to interact directly with the device. And even if it happens to be disconnected, because that's a queuing mechanism, both sides will wait for something to happen. So if some sort of action has happened on the device, it will wait until it has an active connection to go and push that up. If something in the cloud has happened, or in our account has happened and it's in a disconnected state, it'll wait and then push it down when it does have a connection. And we should be able to have two-way communications on and off the device. And we thought that was something that was really interesting. It'd be interesting to hear whether anybody else has played with Greengrass and set something up or built something in real life as well. I know we only have about a minute or so to go, but we'd love to know if people would be interested in going through something like that. We certainly are. We want to do it, but we'd love to know if we're on the right track for what our audience is sort of after. Or if anybody else is going ahead and using it as well.
Yeah, call out if you have used it in the chat. We've only got 1 minute left, and we're going to have to leave fairly quickly. We've got somebody else queued up, I'm sure. We're going to do that later as well. So this is something that we're going to have a little bit of planning to do. We might realize Greengrass is not the way to go, and we might have to rejig things entirely. But hopefully, everyone can learn with us. That's literally our jobs. Is 200 services. Let's have a look at this. Let's see how to use this, and then we go and explore it. And sometimes we're spot on. Other times we've got to redo a little bit. Next week is going to be on Amazon location. So Amazon location is going to be what we're going to explore next week. It went generally available at the start of the month. And so we're going to have special guest star Aaron Semp, another solution architect within Australia, join us, take us through how to use that. And we're going to get hands-on with the new Amazon location service. So hopefully everyone's looking forward to that. We've got to say goodbye now. We're a little bit over time. But thanks for watching us today, and we'll catch you all later.
Take care all. Bye.
Thanks, everyone. Bye.